Assalamualaikum and good morning. My name is Nur Amira Natasha binti Mazri. My matric number is S23B0204. Today I will present my machine learning baseline module for project, individual part. My project is titled Next Day Forecasting of Kijang Emas 1 ounce selling price using a linear regression. So the main goal is we want to predict the gold selling price for the next business day. To do this, we study past price pattern and check how well a linear regression model work as a starting point. From the data set we get from a Bank Negara Malaysia covering the year 2025 until 2026. It have 342 record. Our target variable is y is equal to tomorrow price. We create it by shifting today price forward by 1 day in the data set. Next, we move to the other slide, which is it is data processing. In the data science, the quality of data is everything. If the data is bad, then the model of prediction will be also bad. First, I build a clear data pipeline, and I remove all the format comment and the space from the raw data. That I convert the price value into the number and change the data column into the proper deadline index. Finally, I sort the world data set chronologically. This is a very important to keep the data order safe for our time series model. Next, let's look at the description statistic. We have a 342 record that the average price of our target variable is about 16,946 ringgit. The most important number here is a screener's score, which is 0.1897. In the data science, screeners tell us how a balanced the data graph is because the score is very close to zero. It shows that our data is distribution is a near normal and symmetric like a balanced bell curve. This ideal condition for the ordinary least square like a regression model. One of the key assumptions of a linear regression is the data should follow the near normal distribution. If the data have heavily skewed, the model may be missed by extreme value and produce the wrong straight line. But since our skewness is a 0.1897, the model can draw a stable, accurate, and unbiased straight line to the predict price of tomorrow gold efficiently. Now let's look for EDA process. By visual the data, we can better understand how the market behavior before the training the data. On the left, graph 1 show the price trend over time from 2025 to early 2026. There was a strongly upward trend or bull run reach more than RM 22,000. After that, the price become unstable, which sharp a drop, a small gain. This show a gold price unstable, and our model must handle this change. On the right, the histogram show by model distribution with a two peak many price fall between RM 15,000 and 20,000, meaning the market often state a two main level before moving again. The graph proof the price in is not a simple straight line. That why we use a linear regression as a baseline to test how well a simple line can fit this complex behavior. As we go to features engineering in a machine learning, selecting the right input is the key. Getting an accurate prediction to predict our target harga esok tomorrow price. I engineer five features for our input space X. First is harga semalam. This out a lag one features. It represent the previous price, which capture the most immediately market behavior and momentum. Second is average of 7-day moving. It smooth out the daily random price noise and show the short-term trend direction. Finally, I extract three calendar component: year, month, and day. The features help to the model to detect a potential season, moving or calendar anomalies in gold trading by a combination of all of this. We giving out linear regression model enough meaningful a pattern to make a stable next day prediction. Development. For our baseline algorithm, I select a standard linear regression, but the most critical part of the slide is our validation strategy. Instead of using the standard random key for split, it's strictly implemented by a time series split with a 5 float. In the time series date, uh, random splitting in a huge mistake because it cause of a data leaking, which means the model accidentally use a futures data to predict the past. As you can see in the algorithm time series slip, use a word fraud expanding Win- Windows approach for fraud 1, we train on the past data and test on the next chronology statement. For fraud 2, the Windows aspect editing more past data to test the next features segment. This strict time order assures that our evaluation in 100% realistic and lacking free, which is that a gold standard for time series prediction. So next is crossover validation result. Looking at the table, we can see a clear difference in the performance for to give the best result, which a very low MEE of RM 159 ringgit and 41 cents, and R2 score of is 0.8910. This is showed that during time the gold market was stable and followed a clear linear trend. But the fourth one and for 5, the R2 score dropped into the negative zone. It data science. This drop is important because it's improved the market face suddenly volatility or non-linear score. Since linear regression can only draw a straight line, it struggle when the market change too quickly. This tells us that while a linear regression work as a baseline, it has a clear limitation when the market shifts suddenly. Next, we go to move to final model evaluation. This is where we test our final train model on a completely unseen whole out test set, which is 20% of our total data. The model achieved MAE of 564 ringgit 7 cents, and its RMSE of 689 ringgit 1 cent. Because the RMS is very close to our MEE, it's a proof that our test area are stable and we do not have an extreme 3-hour line area in our prediction. The final R2 score is 0.4743. This means our simple baseline model can successfully explain 47.43% of the price variation on the futures unseen data. For the pure linear regression model prediction, highly violate gold price that is a moderate and acceptable baseline of performance. It serve as a solid foundation before we move into the advanced algorithm. Next, let's look our slide for residual analysis. In data science, residually a simple the prediction error that the difference between a price and accuracy price. If you look the purple histogram, our prediction area are tightly clustered right around the center zero baseline. This is actually what we want to see. It's mean most of our prediction are very close to accurate market price. We also see a very clear bell-shaped distribution with a minimal extreme errors. This balance distribute that our area variation is stable across the data, which is scientific the mathematical assumption of a human homoscedation in the linear regression. In a short, the graph validation that our baseline model is stable, healthy, and its error are completely normal and predictable. So now let's move to the next slide. Is actually a future prediction. If you look the graph, the blue line show the current accurate market trend, where the gold price dropped sharply to around 18,800 ringgit, but our model predict around from the next day up to 19,660 ringgit, shown by the red line. The reason behind the up-down prediction is the 7 days rolling means futures. Since the price fell so quietly, the linear model since it as a temporary drop and use the weekly average to pull the force back for toward the normal level. This show clearly how our features guide the model behavior when the predicting the next business day. To conclude, baseline success set a clear foundation for this project. By using a strict time series split, I assure that our that model evaluation is a complete lack of free on unseen text data. The model achieved an R square score of a 0.4743. This means a simple straight line can explain about 47% of the gold price changing. However, this baseline model have two main limitation. The first is fail during studying a non-linear market shock. Second is lack extreme economic factor like a USD index and inflation rate. Moving forward, the result prove that I need a more advanced model to handle high validation and improve our final accuracy. Thank you.